All right, today we're going to crack open a core framework that top consultants use to cut through complexity and make sharp, data-driven decisions. We're talking about a tool that lets you compare things that seem, well, incomparable. It's called the Z-score, and we're not going to treat it like some dry statistic. We're going to frame it as a powerful lever for building clear, defensible business strategy.
So here's our game plan. First, we'll nail down the core business problem, the whole apples and oranges thing. Then, we'll introduce the solution, which is basically a universal translator for your data. After that, we'll get our hands dirty and build the toolkit, figuring out the mechanics. And finally, we'll put it all to the test with some real-world case studies. It's a logical build, taking you from 0 to 60.
Let's jump right in. One of the biggest headaches in data analysis is always translation. We've got all this important data, sales numbers, efficiency metrics, you name it, but it's all on different scales. It makes the direct, meaningful comparison totally impossible. This is that classic apples and oranges problem that everyone talks about.
Okay, let's make this real. Is an 80 out of 100 on a test better than a 45 out of 60 on another one? I mean, based on the raw percentage, yeah, sure. But that's just scratching the surface. What if that second test was way, way harder, and the class average was in the gutter? All of a sudden, that 45 might be the more impressive score, right? Raw numbers can be super misleading if you don't have context. We need a way to measure performance relative to its own unique situation.
And that brings us right to our solution, the Z-score. Think of it as a universal translator for data. It's this powerful method that lets us standardize any data point from what we call a normal distribution. That classic bell curve shape you see everywhere in business and science. By using a Z-score, we put everything on one single common playing field.
The concept itself is actually beautiful and simple. A Z-score tells you one thing and one thing only. How many standard deviations is this data point away from the average? That's it. If the score is positive, it's above average. If it's negative, it's below. It completely strips away the original units, whether it's dollars or hours or inches, and just gives you a universal measure of where that point stands in the crowd.
And here's where the magic happens. Every single Z-score, no matter where it came from, gets mapped onto this universal yardstick, the standard normal distribution. On this scale, the average is always 0, and the standard deviation is always 1. This standardization is the key step that lets us start doing the cool stuff, like calculating probabilities and making those real, meaningful comparisons.
So, we get the why. Now let's move on to the how. We're going to build out our toolkit, and that means covering how to actually calculate a Z-score and, just as important, how to interpret what it's telling you using a standard Z-table.
The formula itself is pretty straightforward. You take your data point, subtract the mean, and then divide by the standard deviation. Now, you're going to see two versions here. The difference is simple. Are you looking at the entire population of data or just a sample of it? Using the right formula is all about statistical rigor, just making sure your analysis is sound, no matter how much data you're working with.
Once you've got that Z-score, the Z-table is basically your decoder ring. It does two main things for you. First, you can take your Z-score and turn it into a probability. It'll tell you the odds of a value falling below your specific data point. Or you can do the reverse. If you have a target in mind, like say you want to find the top 10% of your performers, you can look up that probability in the table and it'll tell you the exact Z-score you need to hit.
Okay, enough with the theory. It's time for application. We've built the framework. Now let's see what it can do. We're going to walk through 4 totally different business cases to see how this toolkit turns raw data into intelligence you can actually act on.
Our first case study is from healthcare operations. A hospital wants to get a better handle on its patient flow. They know the average stay is about 200 hours, but they really need to plan for those extra long stays. So, the specific question is, what's the likelihood that a patient is going to be there for more than 300 hours?
Okay, let's run the numbers. Our value is 300 hours, the mean is 200, the standard deviation is 75. A little bit of math gives us a Z-score of 1.33. Now here's the crucial part. A standard Z-table gives you the probability to the left of your score. But we want to know about stays that are longer than 300 hours, so we need the area to the right. To get that, we just find the table's value for 1.33, which is 0.9082, and subtract that from 1, or 100%.
And the result? 9.18%. So we can go back to the hospital leadership and tell them with confidence that about 1 in every 10 patient stays is going to require long-term resources.
That's not just a statistic, that's a specific actionable insight for staffing, bed management, and even financial planning.
Now, let's flip the script. The hospital is also worried about stays that are too short. That could mean a patient was discharged too early, which is a big risk. So new question, what percentage of stays last for less than 75 hours?
The calculation is exactly the same process. 75 minus 200 divided by 75. This time we get a negative z-score, negative 1.67, which makes perfect sense, right? We're looking at a value way below the average. And in this case, because we want to know the percentage of stays less than 75 hours, the z-cable gives us exactly what we need right off the bat. The value it gives is the probability to the left.
The result is 4.75%. And again, this isn't just a number, it quantifies a very specific operational risk. It tells the hospital that almost 1 out of every 20 patients falls into this high-risk category. That's a huge signal that they need to go back and review their discharge process, or maybe put some targeted follow-up procedures in place.
Let's switch gears and head to the factory floor. This is a classic manufacturing and quality control problem. A machine is churning out washers. To be acceptable, their diameter has to be between 0.496 and 0.508 inches. Anything outside of that range, either too big or too small, is a defect. So what's the defect rate?
Okay, this case needs a two-sided analysis. We have to calculate a z-score for both the lower and the upper tolerance limits. That gives us z-scores of negative 1.2 and plus 1.2. Now, because a part is defective if it's either too small or too large, we have to find the probability in both tails of the distribution and then add them together to get our total defect rate. And the total defect rate is a staggering 23.02%. In manufacturing, a rate that high is just catastrophic. It means a huge amount of money is being wasted on material and rework. This one number immediately flags this process as a top priority. It's screaming for a process improvement initiative. All right, for our final case, let's look at a marketing or maybe a public health problem. We want to know what slice of our target demographic, in this case, American men, falls within a specific weight range. This could be for designing a new product or maybe a health program.
So this problem is kind of the opposite of the last one. We're not interested in the tails, we want the area between 2 points. The process is similar though. We calculate 2 z-scores, one for the bottom of our range and one for the top. Then, to get just the area in the middle, we find the total probability up to our upper score, and then we just subtract the probability up to our lower score, and what's left over is the exact probability for our target range.
The answer? 95.26%. This tells us that the vast majority of our target demographic falls right inside this specific weight range. And that's a critical insight for all kinds of things: market sizing, supply chain planning, product design, you name it.
So, let's just tie this all together. What are the key takeaways? First, z-scores are your go-to tool for standardizing data so you can finally compare apples and oranges. Second, they reframe every single data point in terms of how many standard deviations it is from the average. And third, the framework for applying this is a simple, repeatable, 3-step process. Calculate your z-score, find the probability, and then interpret that result in a real-world business context.
We've given you the framework and we've shown you how it works in the wild. So now the question really comes back to you. Take a look at your own dashboards, at your own KPIs. What's the very first apples and oranges problem in your work that you are now going to solve? Which 2 different metrics can you finally bring together to find a deeper, more valuable insight? That's the real power of this tool.